The T, or total height parameter, is quite simple to think about. We have some data. It could be roughness, it could be waviness, it could be primary, and we're simply going to report the height of the highest peak relative to the deepest valley. That is the T, or total height of that surface. Let's say that's a roughness profile. That would be RT. That height seems logical. It captures all of the information of the surface, but there's a problem. Our problem is, in practice, the highest peak is usually quite unstable. It could be dirt. So we have this unknown peak that's actually influencing our results and causing us problems. Similarly, there could be a pit or a pore that causes a deep valley that could also be kind of unstable and not actually part of our manufacturing process. So these questionable features, or these unstable features, can make RT or PT a bit of a challenge. The RT or PT parameters can be influenced by dirt, so they're not quite as common in production or in practical use. However, even if we have dirt or porosity or things like this in our data, the waviness version, WT, can be very useful. So the waviness profile is based on smoothing our way through the surface, and in this case, since we're doing some smoothing to get to waviness, the WT parameter is very useful. So WT is the most common waviness parameter, and again, the filtering brings some robustness to the T parameter. Now we'll talk about some other parameters like the Z parameters, which improve on this behavior. So if you're interested in heights for roughness or primary, there are some other options, but the height of the waviness profile is quite stable and reliable through the T parameter.